Okay, so today we're going to go through some tests for similarity using triangles. Now, there are four tests that we're going to go through today. The first test states that if two angles of one triangle are equal to two angles of another triangle, then the two triangles are similar. So let's go through that again. If two angles of one triangle are equal to two angles of another triangle, then the two triangles are similar. Let's give a quick example of that. So let's say I have triangle number 1 and triangle number 2. Now, to test if they're similar, I have to have some information in order to prove that they are similar. So let's put some degrees in here, or some angles, sorry. So let's state this is 40 degrees and this is 60 degrees. And let's state this is 80 degrees and this is 60 degrees. Now, obviously, you can see that the triangles are not drawn to scale. Very rarely within mathematics do we draw triangles to scale. Looking at triangle 1, I can see that I have 40 and 60. So knowing that the sum of all of the angles within a triangle must equal 180, I know that the top angle there is 80 degrees, because 40 plus 60 plus 80 will equal 180 degrees. Now, going through our rule, I can see that 80 and 60 in the first triangle match 80 and 60 within the second triangle. So this proves test 1, that if two angles of one triangle are equal to two angles of another triangle, then the two triangles are similar. So we can see here that these two triangles are similar. Now let's go through test number 2. Test number 2 states that if the three sides of one triangle are proportional to the three sides of another triangle, then the triangles are similar. This means that matching angles are also equal. Now, another way of saying this is side, 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 for anyone who knows similarity in that term. So let's go through and do an example for test 2. For example, if I had two triangles, obviously not drawn to scale, and I stated that the sides of the triangle, for example, this one here is 3, 4, and 5. This one is 6, 8, and 10. Now, looking at this, I have three sides within the first triangle, and I can see that 3 correlates with 6. I can see that 5 correlates with 10, and I can clearly see that 4 correlates with 8. Now, looking at this, the first thing we need to determine for test 2 is, are the three sides proportional to the other three sides of this triangle? Well, I can clearly see that, because if I use these two numbers here, then I can see that 3 to 6 equals 1 over 2. And if I use 5 and 10, again, 5 over 10 equals 1 over 2. And if I use 8 and 4, I can clearly see 4 over 8 equals 1 over 2. So looking at this, I can clearly state that all three sides are proportionate, meaning that these triangles are similar. What does this also mean? This also means that the matching angles are also equal. So for example, if I had angles here of 40, 60, and 80, then that means that in the other triangle, because they are similar, they will also be 40, 60, and 80. So this was test 2 for similarity. Let's go through test 3, similarity. Test 3 states that if two sides of one angle are proportionate to two sides of another angle, and the included angles are equal, then the two triangles are similar. We can also say this as side angle side. So let's go do an example of test 3. So we have triangle 1 with 40 degrees and triangle 2 with 40 degrees as well. And let's state that this is 4 centimeters with 6 centimeters, and I have 2 centimeters with 3 centimeters. Now let's look at the matching side. So I have 4 and 2, and then I have 6 and 3. Now we can see that both of them have 40-degree angles. So the angles are the same. Now, the test 3, it states if two sides of one triangle are proportional to two sides of another triangle, let's have a look. Does it meet the first criteria? Are they proportionate? So if we look at 4 and 2, 4, 2, 2 over 1. And if I look at 6 and 3, 2 over 1 again. So I have 2 over 1 and 2 over 1. That means that both of those sides are proportionate. The second part of test 3 states, and the included angles are equal. So the included angles there of 40 and 40 are equal. This clearly states test 3 is correct. So this means that both those triangles are similar. Let's go through the last test, which is test 4. Test 4 states, if the hypotenuse and a second side of a right angled triangle are proportional to the hypotenuse and a second side of another right angled triangle, then the two triangles are similar. Because this is very similar to side angle side, because we know that both right angled triangles have to have a 90-degree. So let's draw two right angled triangles indicated with the symbol in the corner to indicate they're 90 degrees. Let's go through test 4 once more. If the hypotenuse and a second side of a right angled triangle are proportional to the hypotenuse and a second side of another right angled triangle, then the two triangles are similar. So let's give an example of this. Let's state that this hypotenuse is 12 and this side here is 10 and this is 20 and 24. So the hypotenuse here is 12 and 24. And if we look at those proportions, 12 over 24, we get 1 over 2 as a simplified fraction. Now, if we look at the second set, or the smaller side, looking at these proportions, we get 10 over 20, which equals 1 over 2 as a simplified fraction. 1 over 2, 1 over 2. Now let's go through the test 4 again. If the hypotenuse and a second side of the right angled triangle are proportional to the hypotenuse and a second side of another right angled triangle, then the two triangles are similar. And we can see that they are proportionate, meaning test 4 is correct, so they are similar triangles. So I hope you understood those 4 tests. If you have any other questions, please comment below.